One may ask, what are limits?
You forgot the negative!
For our first unit, we're going to teach you about limits. So we're going to start it off with just some basic graphs, and then later we'll get into the equations. So what a limit is you're basically looking at where a function is approaching, what y value the function is approaching as you approach a certain x value. So for this, we're going to look at the 3. So look at the function. When you approach the value 3, as you approach that x value from the right, you can see that you're approaching the y value of 3. And then, if you approach it from the left, you can see that you're also approaching the y value of 3. So for this function, the limit as x approaches 3 of f of x is going to equal 3. Now, this only works because the limit as it approaches from the right and when it approaches from the left are both 3. If only one side approached 3 and the other approached infinity or 4 or 5, then the limit would not exist. So we're going to look at one of those. Okay, so now we look at this other function, g of x. So now we're going to still be looking at the limit as x approaches 3, but we're going to see that this one is not as simple. So when you approach this one from the right, you see that the y value is approaching 4. But this one, as you approach from the left, the y value is approaching 2. So since they're not approaching the same thing, the limit does not exist. So now we look at the graph of h of x. So as we approach 3 this time, we see that the numbers aren't approaching anything because the y value just keeps getting bigger and bigger and bigger and bigger, and it will never reach any definitive value because, as you can see, there's an arrow pointing to that. So for this one, the limit also does not exist. And sometimes we say that the limit as x approaches 3 from the right is approaching positive infinity, and as it approaches from the left, it is approaching negative infinity. But really what that means is that the limit doesn't exist. So now we're going to deal with trying to find limits while dealing with the equation of a graph instead of just looking at it and estimating. So, right here we have the graph x squared minus 10, which is a parabola. So what you're going to do is we're going to try to find the limit as x approaches 2. So to find the limit as x approaches 2, you have to approach 2 from the left and from the right. So we're going to do this using tables. So we're going to start with 2.1, and then when you do 2.01, that's a little closer to 2, and 2.001 is a little closer to 2. And as you add more and more zeros, you're getting closer and closer to 2. So you're approaching it from the right, because 2.01 would be here, and then 2.01 there, and then 2.001. So we're going to plug x squared minus 10 into our calculator, and then you can go to second window and put in the ask for the independent variable, and then go to second graph. And then you're going to plug in 2.1 first, and you'll get negative 5.59. And then when you plug in 2.01, you get negative 5.96. And then when you plug in 2.001, you get negative 5.996. So as you can see, as you add more and more zeros, you're going to be getting closer and closer to negative 6. So the limit as x approaches 2 from the right is negative 6. And now we're going to do the same thing, but approaching 2 from the left side. So this time you'll do 1.9, then 1.99, then 1.999, and keep adding 9s and see where you're getting closer to. So 1.9, you're going to get negative 6.39. For 1.99, you'll get negative 6.04. And for 1.999, you'll get negative 6.004. So as you can see, this side is also approaching negative 6. So since the limit as x approaches 2 from the right and the limit as x approaches 2 from the left are both negative 6, you can say that the limit as x approaches 2 of x squared minus 10 equals negative 6.
So why do we care about limits? They're especially useful when you have a hole in the graph or a horizontal asymptote. If you think about it, that hole in the graph might be so big on your paper, but it's actually infinitesimally small. You can get to it as close as like 5.99. It still might be defined. 5.999, it might still be defined, but at 6, 6 is the only point. That's a very, very small point where it's not defined.
Isn't that wicked cool?
Duh.
Why are we doing this in calculus? Because of continuity. Continuity is an important concept for taking derivatives. You can't take the derivative of something that's not continuous. So, and in order to find out, as you'll see in later videos, if you want to find out if a function is continuous, you have to be able to take the limit of it at... We'll go over that in later videos. But continuity, asymptotes, holes, those are all important concepts. That's why we're doing limits. That's why these are important.